63 light-years from Earth, there is a planet the color of a deep blue ocean. From far away, it looks almost like home, a soft, familiar, welcoming blue. But that blue is a lie. There is no water here, no oceans, no shore. That blue comes from something falling through the sky, something sharp. On this world it rains glass, molten razor-edged glass. And the glass does not fall down, it flies sideways, driven by winds 7 times faster than the speed of sound. This is a real place. Astronomers have measured its color, its heat, its winds. It has a name that sounds like nothing at all. HD 189,733b. And it may be the most beautiful, most terrifying world we have ever found. Welcome, you're watching To the Moon and Back. Here we travel to the real places science has found in the dark, the ones that shouldn't exist. Today, one planet, one storm, and a kind of weather that could flay a mountain. Let's go and stand beneath a sky that rains knives. To find it, you have to leave everything you know far behind. Past the moon, past Mars, past the cold giants at the edge of our own family of planets. Out past the edge of the solar system, into the true dark between the stars. 63 light-years, light itself, the fastest thing there is, needs 63 years to cross it. A human ship would need millions of years. We will never walk there. We can only look, and looking from this far is almost a miracle. The journey ends in a small, quiet constellation called Vulpecula, the little fox. There, an orange star burns a little smaller and cooler than our sun. It is not alone. A tiny red companion star drifts with it through the dark. And hugging that orange star, impossibly close, swings a single blue world. In 2005, astronomers caught it by watching the starlight flicker. Every time the planet crossed in front of its star, the star dimmed just a little. A dip of barely 2%, a shadow cast across 63 light-years. From that flicker, they knew a planet was there, and that changed everything. Because HD 189,733b crosses its star from our exact point of view. That lucky alignment turned it into a doorway, a rare chance to study an alien world in detail. It is a giant, about the size of Jupiter, the largest planet in our own system. A ball of gas with no solid surface. You could never land, you would only fall. But its size is not what makes it monstrous, its orbit does. It circles its star not in years like Earth, but in barely 2 days. 2 days, that is its entire year, one quick loop and it begins again. To orbit that fast, it must ride terrifyingly close to the fire. 30 times closer to its star than we are to our sun. Closer than Mercury, our sun-scorched innermost world, ever dares to go. At that range, the star is not a distant lamp in the sky, it is a wall of fire. It fills half the heavens, it never sets, it never dims. And under that endless fire, the blue giant began to reveal its secrets. The first secret was the strangest of all, its color. But wait, step back, how do we know any of this is real? How do you study a planet you cannot see, cannot reach, cannot even photograph? For thousands of years, we knew of exactly 8 planets, the ones circling our own sun. Planets around other stars were a dream, a thing of poetry, not proof. The stars were simply too bright, and any planets beside them far too faint. Then, in 1995, everything changed. 2 astronomers found the first one. A planet circling an ordinary star like our sun, 50 light-years away. It won them a Nobel Prize, and it made no sense at all. Because it was a giant like Jupiter, but it orbited its star in just 4 days. A giant planet roasting right next to its star. Theory said that was impossible. Giants were supposed to form far out in the cold, like Jupiter and Saturn did. Yet here one sat in the fire. We called this new kind of world a hot Jupiter. And once we knew how to look, we found them everywhere. So how do you find one? The first trick is to watch the star wobble. A planet's gravity pulls its star just a little in a tiny circle. The star's light stretches and squeezes as it wobbles toward us and away. Read that rhythm and you can weigh a planet you never saw. That is the first method. The second method is even more powerful. You watch the star blink. If the planet's orbit is edge-on to us, it crosses the star's face each lap. And each crossing blocks a sliver of light. The star dims on a perfect schedule. This is the transit method, and HD 189,733b was a gift because it transits. Not only that, its star is bright and close as these things go, just 63 light-years. Bright star, deep transit, dead-on alignment. It became the perfect test subject. The benchmark world, the one every new technique was tried on first. And the greatest trick of all came during those transits. As the planet crosses, a thread of starlight shines through its atmosphere. The air filters that light, stealing very particular colors from it. Every gas leaves its own fingerprint, every atom its own missing color. Read the missing colors, and you read the alien air itself. This is how we learned what a planet trillions of kilometers away is breathing. Not by going there, by catching its starlight and taking it apart. It is one of the most astonishing things our species has ever learned to do. And on HD 189,733b, it revealed a sky no one was ready for. It began with that impossible, beautiful color. Here is a question that sounds simple. What color is a planet you cannot even see? From 63 light-years, HD 189,733b is not a disk. It is not even a dot. It is lost completely in the blinding glare of its own star. The planet's light is a few thousand times fainter than the star's, a candle beside a searchlight. For most of history, measuring its color would have been pure fantasy. Then in 2013, astronomers found a trick, a beautifully simple trick. They aimed the Hubble Space Telescope at the star, and they waited. They waited for the planet to slip behind the star, for it to vanish. This moment is called a secondary eclipse. The planet hides completely. At that instant they measured only the star's light, star alone. Then they waited again for the planet to swing back into view beside the star. Now they measured star plus planet together. Subtract one from the other, and what remains is the light of the planet alone. A sliver of light teased out of a searchlight's glare, and it was blue. Deep blue, cobalt, azure, the first true color ever measured for a planet beyond our sun. A historic first, but it raised a darker question: why blue? On Earth, blue means oceans, sunlight scattering through water and air. So for a heartbeat, you might dream of alien seas on that distant world. Forget it, at 1,000 degrees, no ocean could survive a single second. Any water here is not liquid, it is superheated steam screaming through the air. The blue is not water, it comes from the very stuff the clouds are made of. The atmosphere is laced with tiny grains of silicate, the mineral in sand and glass. Those grains are the right size to catch blue light and scatter it back to space. The same reason our own sky is blue, but built from powdered glass instead of air. So the lovely color is a warning: the sky is blue because the sky is full of glass. The starlight told us more than color, it named the atoms in the air. Sodium, the same metal that flares orange in a street lamp, we found it in that sky. It was among the first atoms ever identified in the air of another world. But even the sodium was strange, its fingerprint was muffled, half buried. Something high in the atmosphere was blurring the view, a thick hanging haze. The very glass haze that paints the planet blue was also hiding its lower sky. A world wrapped in a shroud of glass dust, beautiful on the outside, unknowable within. And where there are clouds of glass, there can be rain of glass. But to understand that rain, first you have to understand the heat. Because everything cruel about this planet begins with how close it sits to the fire. A furnace that never cools, a day that never ends. On one side at least. Because this world has a light side and a dark side, and they never change places. That is where the story turns truly strange. Sitting so close to its star, the planet is caught in a gravitational grip. Its star's gravity has locked its spin. This is called tidal locking. One face is bolted toward the star forever, the other stares forever into the night. On the day side, the sun never moves. It hangs fixed in the sky for all eternity. There is no sunrise, no sunset, no relief, only a permanent blazing noon. Between the eternal day and the eternal night runs a single line around the whole planet. Astronomers call it the Terminator, a ring of endless frozen twilight. On any normal world, twilight sweeps past in minutes. Here, it never moves at all. A place where it is forever almost morning, and morning never comes. Under that fixed sun, the temperature climbs past 1,000 degrees Celsius. Hot enough to melt silver, hot enough to melt gold, hot enough to melt glass. The day side glows a dull furnace red from its own heat, like iron in a forge. Now cross to the night side, turn your back on the star, and still no mercy. You might expect the dark side to be frozen. It is not. It is still hundreds of degrees hot, hot enough to glow faintly in the dark. Something is carrying the star's heat from the day side around to the night. Something is moving heat across the whole planet at a staggering speed. That something is wind, and on HD 189,733b, the wind is a monster. Think of the fiercest hurricane Earth has ever known, around 300 kilometers an hour. Now throw that number away, it is far too gentle for this place. The winds here reach thousands of kilometers an hour, faster than any storm imaginable. The heat gradient between the burning day and the dark night drives them. Air does not drift here, it is flung at the speed of a rifle bullet. The whole atmosphere spins faster than the planet beneath it, a sky that outruns its own world. A single unbroken jet stream wraps the equator, dragging heat around the entire globe. It is this river of wind that carries the fire from the day side to the night. And with that wind comes the sound, though no ear could ever survive to hear it. The winds break the sound barrier many times over, they are supersonic. Every gust arrives before its own thunder, silent and then catastrophic. To measure such winds from 63 light-years seemed impossible. But astronomers found a way to clock the storm, using light and color and motion. As the wind rushes toward us, its light shifts slightly bluer. As it races away, the light shifts slightly redder, the same effect that colors a passing siren. From that tiny shift, they read the wind's speed, around 8,700 kilometers an hour. 7 times the speed of sound, roughly 20 times Earth's worst hurricane. A wind that could strip the paint, then the metal, then the memory off anything in its paths. And this wind does not blow through empty air, it blows through clouds of glass. Now we come to it, the thing that makes this planet a legend, the rain. High in the atmosphere where it is coolest, the silicate vapor condenses. Gas becomes grain, grain becomes droplet, droplet becomes molten glass. On Earth, heat lifts water, it cools, it condenses, it rains, a gentle, familiar cycle. Here the very same cycle runs, but with rock in the place of water. Heat lifts silicate vapor, it cools high up, it condenses into glass, and it falls. A rock cycle in the sky, a weather system built entirely out of melted stone. Clouds form, not clouds of water, but clouds of tiny, glowing liquid glass. And like any cloud, when the droplets grow heavy enough, it rains. But this is where Earth's rules end. On Earth, rain falls gently down. Here, the winds are so violent that rain can never fall straight. The moment a glass droplet forms, the supersonic wind seizes it and hurls it sideways at thousands of kilometers an hour. Picture it, a storm of liquid glass flying flat across the sky like tracer rounds. Not droplets drifting down, but glowing needles screaming past, edge on. Each one hard enough to cut, fast enough to punch straight through steel. A rain that does not soak you, a rain that sandblasts you into nothing. This is not a gentle drizzle, it is a planet-wide fire hose of molten shrapnel. Stand in it for a heartbeat, and there would be nothing left of you to fall. No spacesuit could hold, no hull could last, no shelter could stand against it. There is no life here, there cannot be, not as we could ever imagine it. And yet it is not dead in the way a rock is dead. It roars, it rages, it moves. A world with no heartbeat, and yet more furious than any living thing. And it never stops, there is no calm season, no clear morning after the storm. The wind never dies, the heat never fades, the glass never stops flying. For millions of years, this same storm has raged across the same blue sky. And it will keep raging long after our own sun has died. How can we possibly know all this from so far away? It sounds like pure imagination. But it is not a guess, each cruel detail was read from starlight itself. When the planet crosses its star, a little starlight filters through its atmosphere. And the gases and grains in that air each stamp their fingerprint on the light. Silicate haze, water vapor, even the temperature layer by layer. Yes, water, there is water on this planet, that surprises almost everyone. But do not picture a drop of it. At 1,000 degrees, water cannot be liquid. It exists only as scorching steam, woven invisibly through the glass and the fire. A planet with water in its sky, and not one drop you could ever drink. From a thread of filtered light, we reconstructed an entire alien sky. We even built a weather map, a map of a world no telescope can truly see. Back in 2007, this planet gave us the first weather map of any world beyond our own. A space telescope watched it for hours as it rotated its hot face toward us, then away. From the changing glow, astronomers drew the temperature, point by point, around the globe. The first true weather report from another star system, and it revealed the wind. The hottest point, we learned, is not directly under the star. The wind drags it off-center. Proof of the storm written in temperature. The wind literally smears the heat around the globe. A weather forecast for a planet 600 trillion kilometers away. And the forecast is always the same, molten glass sideways at the speed of a bullet. You might think a planet like this is at least eternal, locked, burning, but forever. It is not. HD 189,733b is dying. Slowly, spectacularly, it is boiling away. So close to the star, it is battered by radiation and stellar wind. That relentless energy heats the top of the atmosphere until it simply escapes. The planet is leaking its own sky into the void, thousands of tons every second. The escaping gas trails behind it, forming a vast glowing tail. A planet with the tail of a comet, streaming across 63 light-years of dark. And its star does not die quietly either. It flares, it rages. Astronomers once watched the planet's atmosphere puff up violently after a stellar flare. In a matter of hours, a burst of X-rays from the star tore gas off the planet in a great gust. We did not just theorize this, we caught it happening live 63 light-years away. The star breathes fire and the planet flinches and bleeds a little more into space. Over billions of years, this is a slow execution. The star is devouring its own child. One day far in the future, the storms of glass may have nothing left to fall through. The blue will thin, the winds will fade, the rain will finally at last stop. But not for a very, very long time. For now, the storm still rules. So let us go there in our imagination, a journey no one will ever truly make. Begin in orbit. Below you, the whole blue globe turns, glowing faintly with its own heat. You fall toward it, the blue rises to meet you, vast and shining and wrong. You pierce the outer haze. Instantly the light turns a deep, electric sapphire. The temperature outside your imagined craft climbs past anything Earth has ever known. Deeper, and the first glass clouds appear, shining like galaxies of molten beads. Then the wind takes you, and you understand at last what sideways rain means. So let us stand there in our imagination one last time, just for a moment. Above you, an orange sun fills half the sky and never moves. The air around you glows electric blue, thick with shining dust. The ground, if you could call it that, is only deeper cloud falling away forever. And across that whole sky, from edge to edge, the glass is flying sideways. Silent at first, then a roar louder than anything alive could bear. It is the most violent weather ever discovered, and it is absolutely real. Not science fiction, not a painting, a real planet turning in the dark right now. While you breathe, while you blink, that glass is flying. It has never once stopped. 63 light-years away, a blue world it rains knives on forever. And here is the thought that should keep you up tonight. HD 189,733b is not rare. It is just the first monster we managed to see clearly. There are billions of planets in our galaxy, billions upon billions. More planets than there are grains of sand on every beach on Earth. And we have only just begun to look, a few thousand out of that endless ocean. One telescope alone stared at a single patch of sky for years, watching for blinks. In that one small patch, it found thousands of new worlds, from one keyhole of the sky. Multiply that across the whole sky, and the numbers stop making sense. Most stars we now believe have planets. Worlds are the rule, not the exception. Among the ones we have found, there are worlds stranger than any story. Meet WASP 76b. On its day side, it is so hot that iron itself evaporates. The iron vapor blows to the cooler night side, condenses and falls. It rains iron there. Meet 55 Cancri E, a world twice Earth's size that may be part crystal, part ocean of lava. Its surface bakes at over 2,000 degrees. A sea of molten rock under a giant sun. Meet Kelt 9b, the hottest planet we know, hotter than many actual stars. It is so hot its atmosphere is being torn apart into raw, glowing atoms. Meet WASP 12b, a world in the act of being swallowed by its own star. Its star is pulling it apart and eating it, one stream of gas at a time. Beside these, our own planets seem almost boringly, wonderfully safe. HD 189,733b was one of the first to teach us just how wild reality can be. It taught us to measure a color across 63 light-years, to weigh a wind, to map a storm on a world we will never touch. Every impossible measurement here became a tool for the next discovery. And now, a new generation of telescopes has opened its eyes. A giant golden eye, 1,000,000 miles from Earth, drinking in the faintest infrared light. It can do for many worlds what took years of effort for this one blue giant. Instruments so sharp they can taste the air of worlds even further away. Sniffing for water, for clouds, for the faint chemistry of life itself. Somewhere out there, past the glass rain giants and the lava worlds, there may be a planet that is not a monster at all. Not too close to its star, not too far, not too hot, not too cold, just right. Astronomers call that gentle band the habitable zone, the place where water could stay liquid. We have already found small, rocky worlds sitting quietly inside that band. Around one dim red star, 7 Earth-sized worlds circle in a tidy chain, some in the sweet spot. We do not yet know their skies, but we are learning to read them one by one. A quiet blue world where the blue really does mean oceans, and rain really does fall soft. We do not know if we will find it, but because of worlds like this one, we know how to look. Every terrifying planet we decode makes the gentle ones easier to find. The universe is not empty and it is not quiet, it is crowded with the unbelievable. Glass rain, iron rain, diamond ground, suns that never set. All of it real, all of it out there, all of it waiting to be understood. And it all began for so many of us with a single impossible blue dot. 400 years ago, we thought the Earth was the center of everything. Now we know it is one small world, among billions, around one ordinary star. And some of those other worlds rain glass and iron and fire. The universe turned out to be stranger and grander than anyone dared to imagine. A planet where it rains glass sideways at the speed of a bullet. If this world blew your mind, then you belong here. This channel is a map of the strangest real places in the cosmos. Subscribe, and every week we will travel somewhere no human will ever stand. Tell me in the comments, would you visit HD 189,733b if you could watch from orbit, safe behind glass? There is so much more dark out there, and so much more to find. Thanks for watching To the Moon and Back. Keep looking up.